All right, today we will be taking care of Chapter 1, Lesson 9. Today we're going to learn about direct variation. On page 81 in your textbook, it says the distance d a car travels after t hours can be represented by d equals 65t. The table and the graph also represent the situation. So we have this equation, d equals 65t. We could also write that as y equals 65x, where x is the time and y is the distance in miles. So we talked about this last week about writing equations from the given data. It says here, fill in the blanks to find the constant ratio. So distance traveled, y, over driving time, x. And they have 130 over 2, 195 would go over 3, and 260 would go over 4. If you divide each one of those ratios, the constant ratio ends up being 65 miles per hour. Also, when we divide y by x, which is what we just did, we know that if we get the same ratio each time, that the situation is proportional. We also can tell that this situation is proportional because the graph of the situation forms a straight line that goes through the origin. Now take a look at question number 2 here. It says the constant rate of change or slope of the line is change in miles over change in time, or change in y over change in x. That's where we use that little delta symbol or triangle. So change in y over change in x. Well, let's see what happens when we find that out of this data. They took the two lowest points, 2, 130 and 3, 195, and they subtracted the change in y, 195 minus 130, and they subtracted the change in x, 3 minus 2. And what they came up with was 65 miles per hour. So the change in y over the change in x was the same as y divided by x. And we learned that in a proportional situation, this was going to be true. That not only was the change in y over change in x going to equal the unit rate, but also y divided by x was going to equal the unit rate. So here we have this constant ratio and this constant rate of change, and they are the same thing. And notice in our equation of y equals 65x, the 65 in front of the x is that number. It's that constant ratio. It's that constant rate of change. It's that slope. They are all the same thing because this situation is proportional. So what is a direct variation? A linear relationship is a direct variation when the ratio of y to x is a constant, k. We say y varies directly with x. So y over x equals k, or y equals kx, where k is not equal to 0. For example, it says y equals 3x, but that's actually not correct. It should say y equals 2x. That is a typo in the book. Is represented by this graph, y equals 2x, where if you notice, first of all, it is proportional because it is a straight line going through 0 on the graph. And in addition, it goes up, or goes over 1 up 2, over 1 up 2, over 1 up 2. The slope is 2 over 1 because the change in y over the change in x is 2 over 1, or 2. At the same time, if I divide y by x, I get 2 over 1 or 2. So whether I find the slope or I find the ratio, constant ratio, it's the same. It comes out to be 2, which is why there is a 2 in front of that x. It says when two variable quantities have a constant ratio, the relationship is called a direct variation. The constant ratio is called a constant of variation. The constant of variation is also known as the constant of proportionality. So let's talk about that for a second. If there is a constant ratio, we have what's called a direct variation, which has a constant of variation. And the constant of variation is the same as the constant of proportionality. Well, if we go back to this, we said this situation is proportional. And when we divided all the y's by all the x's, 130 divided by 2, 195 divided by 3, and 260 divided by 4, we found that they were all the same. This is what we did when we determined if a situation was proportional. Constant of proportionality. The constant of proportionality in that example was 65 miles per hour. That is also the constant of variation, because whenever you have a proportional situation, not only is it proportional, it's also a direct variation. A direct variation is the same as saying the situation is proportional. So direct variation is the same as proportional. They're the same thing. And the constant rate that we found when we divided y by x is called the constant of variation or the constant of proportionality. Those words are interchangeable because direct variation and proportional are interchangeable. So they're the same thing. So take a look at this. Is this situation proportional? Hopefully you're looking at it and going, yes, it's a straight line through the origin. Of course it's proportional. Since it is proportional, it's going to have a constant rate, a constant of proportionality and a constant of variation. What is that constant of proportionality or that constant rate? Well, we simply need to take and find it by saying A, our constant of variation or constant proportionality, is equal to y divided by x. And we need to take the y's and divide them by the x's. Remember, when we list out points, x is listed first, y is listed second. So in this graph, the smaller numbers are the y numbers. So we have 2 over 5, we have 4 over 10, we have 6 over 15, we have 8 over 20. If I simplify that down to the simplest form, it actually comes out to be 2/5. I can just box that one in and say, hey, k is equal to 2/5. But in addition, if I wanted to divide them, I would find out that they are all equal to 4/10, 0.4, which is also that fraction right there where it's not reduced. So either one of these answers is correct, 2/5 or 4/10. If I asked you for the slope, you would have to tell me it's 2/5. If I asked you for the constant of proportionality or the constant of variation, you can tell me that it is 4/10. So there is a direct variation here. So it is 0.4 or 2/5 inches per minute, right? Let's move on to example 2. It says the equation y equals 10x represents the amount of money Julio earns for x hours of work. Identify the constant of proportionality. Explain what it represents in this situation. So we have y equals 10x. And we're looking for, what is K? Well, K is 10. We just have to look right there in front of the X, because the constant of proportionality, or the constant of variation, is going to be that number that gets multiplied times X. But in this situation, what does that really mean? It means that Julio makes $10 per hour, because we're taking 10 and multiplying it times X hours. So it's $10 per hour of work. So you would say $10 per hour. Take a look at example 3. It says not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. So let's go back again, think about last Thursday and Friday. Most of the situations we saw that were proportional. In other words, y divided by x was the same as the change in y over the change in x. But there were a few situations we looked at, like this one, where, hey, it's not proportional. That line doesn't go through the origin. If I come up here and I go, okay, what is y divided by x? 11 divided by 1, 19 divided by 2, 27 divided by 3, and 35 divided by 4. What I find is this is 11. 27 divided by 3 is 9. Those are not the same. 19 divided by 2 would be 9.5 or 9.5. 35 divided by 4 is 8.75. So we don't get the same answer when I divide y by x. That means there is no constant of variation. There is no constant of proportionality, because this situation is not proportional. This is not a direct variation. It's not proportional. It's not a direct variation. But does it have a constant rate of change? Yes, it does. It's a straight line. It has to have a constant rate of change. Take a look at these 2 points right here. 19 minus 11 is 8. 2 minus 1 is 1. So there is a constant rate of change of 8. There is a slope of 8, but this is not proportional, so it is also not a direct variation. And finally, number 4, it says determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. Okay, the constant of proportionality, again, we're going to call that K, has to equal y over x and has to be constant, has to be the same for every one of the ratios, for every one of the y-x ratios. So let's see if this is constant. We get 12 over 1, 24 over 3, 24 over 2, 36 over 3, and 48 over 4. 12 over 1 equals 12. 24 divided by 2 equals 12. 36 divided by 3 equals 12. 48 divided by 4 equals 12. All of those ratios are equal to each other. So we can say that K is equal to 12, and it happens to be $12 per, well, it says per time, so we're going to assume per hour. So dollars, it says per time, we're going to say that that's an hours. So yes, there is a K, so this situation is proportional. This situation is a direct variation. So we would say, yes, K equals 12.